Photographic plates preceded photographic film as a capture medium in photography. The light-sensitive emulsion of silver salts was coated on a glass plate, typically thinner than common window glass. Instead of the clear plastic film, glass plates were far superior to film for research-quality imaging because they were extremely stable and less likely to bend and distort, especially in large-format frames for wide-field imaging. Early plates used the wet collodion process. The wet plate process was replaced late in the 19th century by gelatin dry plates. Glass plate photographic material largely faded from the consumer market in the early years of the 20th century, as more convenient and less fragile films were increasingly adopted. However, photographic plates were reportedly still being used by one photography business in London until the 1970s, and they were in wide use by the professional astronomical community as late as the 1990s. Workshops on the use of glass plate photography as an alternative medium for artistic use are still being conducted. A view camera nicknamed the Mammoth, weighing 1,400 pounds, was built by George R. Lawrence, Indiana, 1899, specifically to photograph the Alton Limited train owned by the Chicago and Amp Alton Railway. Took photographs on a single glass plate measuring 8 feet by 4.5 feet. Scientific uses. Astronomy. Many famous astronomical surveys were taken using photographic plates, including the first Palomar Observatory Sky Survey of the 1950s, the follow-up POS-2 survey of the 1990s, and the UK Schmidt survey of southern declinations. A number of observatories, including Harvard College and Sonneberg, maintain large archives of photographic plates, which are used primarily for historical research on variable stars. Many solar system objects were discovered by using photographic plates, superseding earlier visual methods. Discovery of minor planets using photographic plates was pioneered by Max Wolf, beginning with his discovery of 323 Brucia in 1891. The first natural satellite discovered using photographic plates was Phoebe in 1898. Pluto was discovered using photographic plates in a blink comparator, its moon. Charon was discovered 48 years later in 1978 by U.S. Naval Observatory astronomer James W. Christie by carefully examining a bulge in Pluto's image on a photographic plate. Glass-backed plates, rather than film, were generally used in astronomy because they do not shrink or deform noticeably in the development process or under environmental changes. Several important applications of astrophotography, including astronomical spectroscopy and astrometry, continued using plates until digital imaging improved to the point where it could outmatch photographic results. Kodak and other manufacturers discontinued producing most kinds of plates as the market for them dwindled between 1980 and 2000, terminating most remaining astronomical use, including for sky surveys. Physics. Photographic plates were also an important tool in early high-energy physics, as they get blackened by ionizing radiation. For example, in the 1910s, Victor Franz Hess discovered cosmic radiation as it left traces on stacks of photographic plates, which he left for that purpose on high mountains or sent into the even higher atmosphere using balloons. Electron microscopy. Photographic emulsions were originally coated on thin glass plates for imaging with electron microscopes, which provided a more rigid, stable and flatter plane compared to plastic films. Beginning in the 1970s, high-contrast, fine-grain emulsions coated on thicker plastic films manufactured by Kodak, Ilford and DuPont replaced glass plates. These films have largely been replaced by digitally imaging technologies. Medical imaging. The sensitivity of certain types of photographic plates to ionizing radiation is also useful in medical imaging and material science applications, although they have been largely replaced with reusable and computer-readable image plate detectors and other types of X-ray detectors. Decline. The earliest flexible films of the late 1880s were sold for amateur use in medium-format cameras. The plastic was not of very high optical quality and tended to curl and otherwise not provide as desirably flat a support surface as a sheet of glass. Initially, a transparent plastic base was more expensive to produce than glass. Quality was eventually improved, manufacturing costs came down, and most amateurs gladly abandoned plates for films. After large-format, high-quality cut films for professional photographers were introduced in the late 1910s, the use of plates for ordinary photography of any kind became increasingly rare. The persistent use of plates in astronomical and other scientific applications started to decline in the early 1980s as they were gradually replaced by charge-coupled devices, which also provide outstanding dimensional stability. CCD cameras have several advantages over glass plates, including high efficiency, linear light response, and simplified image acquisition and processing. However, even the largest CCD formats still do not have the detecting area and resolution of most photographic plates, which has forced modern survey cameras to use large CCD arrays to obtain the same coverage. The manufacture of photographic plates has been discontinued by Kodak, Agfa and other widely known traditional makers. Eastern European sources have subsequently catered to the minimal remaining demand, practically all of it for use in holography, which requires a recording medium with a large surface area and a submicroscopic level of resolution that currently available electronic image sensors cannot provide. In the realm of traditional photography, a small number of historical process enthusiasts make their own wet-to-dry plates from raw materials and use them in vintage large-format cameras. Preservation. Several institutions have established archives to preserve photographic plates and prevent the valuable historical information from being lost. The emulsion on the plate can deteriorate. In addition, the glass plate medium is fragile and prone to cracking if not stored correctly. Historical archives. The United States Library of Congress has a large collection of both wet and dry plate photographic negatives, dating from the 1855 through 1900, over 7,500 of which have been digitized from the period 1861 to 1865. The George Eastman Museum holds an extensive collection of photographic plates. In 1955, wet plate negatives measuring 4 feet 6 inches by 3 feet 2 inches were reported to have been discovered in 1951 as part of the Holtzman collection. These purportedly were the largest glass negatives discovered at the time. These images were taken in 1875 by Charles Bayliss and formed the shore tower panorama of Sydney Harbour. Albumen contact prints made from these negatives are in the holdings of the Holtzman collection. The negatives are listed among the current holdings of the collection. Scientific archives. Preservation of photographic plates is a particular need in astronomy, where changes often occur slowly and the plates represent irreplaceable records of the sky and astronomical objects that extend back over 100 years. An example of an astronomical plate archive is the Astronomical Photographic Data Archive at the Pisgah Astronomical Research Institute. APDA was created in response to recommendations of a group of international scientists who gathered in 2007 to discuss how to best preserve astronomical plates. The discussions revealed that some observatories no longer could maintain the plate collections and needed a plate place to archive them. APDA is dedicated to housing and cataloging unwanted plates, with the goal to eventually catalog the plates and create a database of images that can be accessed via the Internet by the global community of scientists, researchers and students. APDA now has a collection of more than 200,000 photographic images from over 40 observatories that are housed in a secure building with environmental control. The facility possesses several plate scanners, including two high-precision ones, Gamma-I and Gamma-2, built for NASA and the Space Telescope Science Institute and used by a team under the leadership of the late Dr. Barry Lasker to develop the Guide Star Catalog and digitize Sky Survey that used to guide and direct the Hubble Space Telescope. APDA's networked storage system can store and analyze more than 100 terabytes of data.